Okay, I would like to work on this another day, please. Simplifying with radicals. Remember, I have a kind of way to do this. There are other ways to do it, but this is the best for when you get to a test and you're ready for everything thrown at you. Okay, you have a square root, and inside you got 8y to the 5th, times, and you have a square root, and inside you got 40y to the 2nd. So, since they're both square roots, you make it into a half power, and then you times 8 times 40 is going to be 320. Then y to the 5th times y to the 2nd is y to the 7th. You add the exponents. Okay, now you set up your exponent properties. And again, when you see those fraction exponents, that means you want to be looking at 6 things. So you have 320 times y. So 1 times 1/2 is 1/2, and then 7 times 1/2 is 3.5. None of them are negative. Okay. Now you circle the 1 whole exponent, you just transition that over, and then you put these two together. So times 320 to the 1/2 times y to the 1/2. Now, circle the 2's, check your list of square roots, and see if 320 is there. 320 is nowhere to be found, so and y won't be. Okay. You don't have anything on bottom to really look at, So you got your y to the 3rd, and then the ones with fractions, you make square roots. 2's the only one I got, so I make a square root, and then 320 to the 1st, which would be 320, times y to the 1st, which is y. Okay, now simplifying, we got y to the 3rd, and then in the radical, you put your variable, but you want to see how much of that 320 you can take out of there. Can't take it all out because otherwise that would have worked up there. But so square roots, you got to be looking at the right list. So 320, 225 doesn't work. 196 doesn't work. 169 doesn't work. 144. 100's a no-go. 81, and be patient, 64. Okay, so 64 and 5. Now the 5 stays in. 64 goes out as 8. Okay, not as 64. So there's your answer. 8y to the 3rd times the square root of 5y. Okay, next one. We have a square root of 8x to the 5th times the square root of 3x. Okay. So you make a 1/2 power. By the way, what you're some of you might ask, what if that's a 2 and that's a 3? Then you'd have to make 2 separate ones, okay, with a times. But they're the same, so I can make them both 1/2. So 8 times 3 is 24, and then on x to the 5th, x to the 1st would be x to the 6th. Okay, so the base is you have 24 times x. So 24 is to the 1st, 1 times 1/2 is 1/2, 6 times 1/2 is 3. No negatives, circle your hole, bring it over, and then put your rational, the base with the rational exponent goes second, and then circle that. Is 24 on your list of perfect squares? No, it's not. Okay, so can't get rid of it completely on the spot. Don't have anything on bottom to worry about. Now x to the 3rd, and then I transition that 1/2 power back into a square root. And inside 24 to the 1st, which is 24. So you got your x to the 3rd. Now make your radical. Now you need to simplify the square root of 24. Make 2 square roots. So 24 divided by 16. Nope. Nope. Yup. So 4 and 6. So put them in that order, because then you know that the 6 stays, but the square root of 4 comes out as a 2. Okay, and there you have it. 2x to the third times the square root of 6. Okay, next problem. We have 3 with a cubed root over 5y to the third times 2 with a cubed root of 50y to the fourth. So we multiply the outsides 3 times 2. That's going to be 6. Then I make a parentheses. They're both cubed roots, so it'd be to the 1/3 power. Okay, 5 times 50 is 250. Y to the third times y to the fourth is y to the seventh. Now we're ready to go through our exponent properties. So we have 6 times 250 times y. So 6 to the first is 1 times 1/3 is 1/3. 7 times 1/3 is 2 1/3. So here are your whole exponents. Don't forget, that's actually 2 bases of y. Y to the second, you're going to split it into a y to the second, and later on a y to the 1/3. So you put the 6 to the 1, don't need that. The only thing you'd need that for is if you had a negative exponent and you had to move it to the other side. Okay. Okay, then position your rational exponents. And then circle the bottom as you do that, because we're going to check our list. So let's look at your cubed roots. Is 250 on that list? Nope. And then the variable's never on the list. Okay, nothing to worry about on bottom. So we got 6 to the first, y to the second, and then when I get to the rational exponents, they're both 3's, I make my radical. Cubed root, 250 to the first, and then y to the first. Okay. So 6 to the first is 6, y to the second can't be simplified. And then the cubed root, the y can't be simplified, but I think there's a possibility, good possibility, that the cubed root of 250 can at least be simplified. Okay. Remember, you got to look at the right list. You're on cubed roots. So 250 divided by 216 decimal. 250 divided by 125, 2. So I got 125 and 2. So the cubed root of 125 is 5. So the 2 will stay there, and I put a times 5 there, and then you need to multiply 5 times 6, which is 30. So that's your answer, 30 times y to the second times the cubed root of 2y. Okay, the fourth root of 27 times the fourth root of 6, okay? So, a 1/4 power, and I take 27 times 6. We don't have any variables to worry about here. So you have 162. 1 times 1/4 is 1/4. No whole exponents, so you just put the 162 to the 1/4, and when you do that, circle the bottom. Now do a root check. Look at your fourth root. Is 162 actually here? No, it's not. Okay, so I can't simplify it completely. Nothing on bottom. Now, that's the only base you have, and it's a rational exponent. So you make a 4 and a 162 to the first would just be 162. And remember, we want to try to simplify that. Okay, so fourth root, so 162 divided by 81 is 2. So you position 2 inside. That's not 9. Look at the list. The fourth root of 81 is 3. Because 3 times 3 times 3 times 3. So 3, fourth root of 2. Alright, now dividing. Same idea. We have the square root of 50 divided by the square root of 5. Okay. So 1/2 power. And then I divide 500 by 5. That's going to be 100. Okay. So you have 100. 1 times 1/2 is 1/2. Okay, that's the only base you have. There's no whole exponents, so circle there. And square root of 100, I think if 100's there, so you get to cross it out right here and put 10. It's 10 to the first. Okay, so you have 10 to the first, and that's just 10. Okay, easy. Okay, next one, you've got the square root of 48x to the third divided by the square root of 3xy to the second. So you make it to the 1/2 power, because they're both square roots. Okay, and then 48 divided by 3 is going to be 16 on top. And then x to the third, x to the first, so you cross out the first, minus it to the top, and it's x second on top. Now the y to the second, there's no y on top, so we just leave a y to the second on the bottom in the denominator. Okay, so 1 times 1/2 is 1/2, 16 to the 1/2 power. 2 times, and then x and y. So 2 times 1/2 is 1, 2 times 1/2 is 1. So none of them are negative. So pull, your whole numbers are here. So you got x to the first, y to the second. Now you drag the other one over here, 16 to the 1/2 power, and circle the 2 on the half, because you get to go, that means the square root of 16. So you look at the list of 2, and the square root of 16 is 4. Okay? So 4 to the 1. See, I'm able to simplify if I do what that's called a root check. Okay? Okay, now you have an exponent on bottom, but it's not a fraction exponent. Okay. Okay, so we're going to have 4 to the first. I usually put the number first, times x to the 1, and then y to the 1. Now there's no rational exponents because I got rid of it right there, so I don't need to put a radical. Okay? So 4 to the first is 4, x, and y. So you don't have any more fraction exponents, so that's why you don't have to make a radical right there. Okay, last two. I've got the cube root of 250 x to the 7th, y to the 3rd, and divided by the cube root of 2x to the 2nd, y. So you make a 1/3 power, divide what you can. 250 divided by 2 is 125, so that's on top. X 7th, x 2nd, so I cross out the x 2nd minus 2, and that's x to the 5th. Okay, now on the y's, a y to the 3rd and a y to the 1st, so we cross out the y to the 1st minus 1, and that's y to the 2nd. Okay. Okay, so we have 125 times x times y. They're all on top. So 1 times 1/3 is 1/3. 5 times 1/3 is 1 2/3. Then 2 times 1/3 is just 2/3. So you have one whole number exponent, x to the first. You just pull that over and cross it out. Now write down all your rational exponents. So times 125 to the 1/3 power, times x to the 2/3 power, times y to the 2/3 power. Now circle all the bottoms. So we're on the cube roots. 125 is here, so you do a root check. The 125 simplifies into 5. So now, instead of 125 to the 1/3, it's 5 to the first. And x and y can't be. But we were able to do something, okay? So you now have x to the first, you have 5 to the first, and then you have rational exponents. Rational means they have fractions, okay? So the bottom is 3. So you make one cubed root, and inside you put x to the 2nd times y to the 2nd. Okay, so x to the 5 to the first would be 5. Do the 5 before the x to first. X to first would be x. And then in my cubed root, I have nothing but variables, so I don't have to simplify, okay, because I know those variables can't be. Okay, last problem. We got the cubed root of 48 x to the third y to the second divided by the cubed root of 6x to the second y. So they're both cubed roots. Everything's in a cubed root, so make it into one big 1/3 power. 48 divided by 6 is 8. 8 takes the top then. X to the third, x to the second. So we get rid of the second, minus 2 from the x to the third, and that'd be x to the first. Okay. Then y to the second, y to the first, I would take 1 away from y to the second, and that would be y to the first. Okay. So we got 8x and y. So my base is all on top. The bottom is gone. 8 times x times y. They're all to the 1, but they all need to be multiplied by 1/3, so they would all become 1/3. I'm crossing that out because there's no negatives. Now you don't have any whole exponents, you just line up all your rationals. Circle the bottom as you're lining those up. Okay, now do a root check. Look at your cubed root list. 8's right there, Holmes. So that's now 2 to the first. Okay, and the fraction's gone. The x and y you can't eliminate. Nothing on bottom. So 2 to the first. And these ones that have bottoms, okay, bottom exponents, we make that into a cubed root with x to the first times y to the first. So 2 to the first is 2. And in the cubed root, you can't simplify, okay, because they're just variables, but it'd be x times y with a first power.